Hello, whoever's watching this videos. It is 1 a.m., but the deadline is coming up. We only have today, tomorrow, and Monday to get this thing done. So what we're going to do is we're going to write up our slope collision detection. So we're going to go to our platform class, and we're just going to write it up. So hit slope. This part is going to be a little bit more involved, but it's really, but if you think about it, it's really pretty simple. Now again, we're just gonna come on. All right, we're just gonna set the section all the way at the end. Just might as well do it now. If we checked everything and nothing happened, just want to get rid of this error message that it's not returning a boolean because I'm OCD. Equals to false. Now on slope, because we're dealing with the slope, not on platform, and we're just going to return false. Reach run. Perfect. Okay, now what are we going to do? Hit slope. Alright. Now we should make a comment here. We're going to finally make use of the laws of similar triangles that we learned back in elementary school. So finally, some actual applications of the things that we learned. Alright, I think I should just first illustrate, as usual, what we're going to do with GIMP here. And let's just create a new one. So what we're going to do is, let's check out what a slope is. And here's a free math lesson for you guys. So let's say we have the slope, right? And we have point number 1 and point number 2. And let's say that this is x1 and y1. Geez, I don't know why I'm giving a math lesson, but whatever. Let's do it anyways. And this is x2, y2. It's a free math lesson, guys. You should be paying me, but hey, you know, I'm a nice guy. You don't need to pay for this one. Okay, so we have our x1, x2. So what we're going to do, and let's say that our player's position, let's say that our player's feet, right, our Nekko, well, let's just grab it. Our Nekko. Let's say our Nekko is jumping. Let's scale the layer. Hey. Scale layer, make it percent, 200%. Okay, so we have our Nekko over here, and again, we're going to be detecting if his feet has hit the platform. So right there, his feet. And I guess we should create a new layer for this. And let's say his feet has a coordinates I'll just say C1 and B1 and C1. And I guess we should make it something else, the color, that is, of the text. Maybe okay. Now, what we're gonna do is we need to know we need to know a couple of things. We need to know one thing for we're going to be checking two components. We're going to be checking the horizontal component, and we're going to be checking the vertical component. So, well, are we really going to be doing this? No. Sorry about that. We're just going to be checking the horizontal component and see if our Nekko, if this point right over here hits this platform. So it's essentially the same thing as hit platform, except we are given these 2 points over here with differing x and y values. So what we're going to need to do, and once we do it, it's going to be almost exactly the same as hit platform, is we need to find out what this line is. We need to find out, well, we already know. So, okay. So this is our x value, right? Let's just draw it. Just draw it properly. Oops. So this is gonna go over. I don't know how to draw a line. Right over here. Right? Now, what we need to do is find out, well, we already know the x position of this. This is equal to this point right over here is equal to what? It's equal to b1 for the x value, and it's equal to a question mark y value. We don't know the y value. So what we need to do is solve for y. Now, you can probably already see the answer. It's really very simple. Using the laws of similar triangles, what we're going to do is we know that we have two triangles here, right? We have the big triangle, because what we're looking for is this y value. Once we have this y value, we can basically do what we did for hit platform. So once we get this y value, we basically have this, which is a platform, because we have x1, we have x2, and we have y1, which is basically what we use to detect platforms, horizontal platforms. So once we get this y value, everything will be pretty much almost the same thing as we did before on hit platform. So without further ado, let's move on to the law of similar triangles. What we're going to do is so we have a big triangle here, and we have we have a small triangle here. Okay. Now, what we need to do, and we have this angle. Which angle are we going to be using? This angle, theta. We're going to call it theta. What can we get from this? Opposite over hypotenuse. No, sorry. So tangent. Opposite, right. So what we're going to do is we know this, right? We know that, and we know the length of this. The length of this is nothing but y2 minus y1. I'm not even going to type that up. Fine, screw it. This is y2 minus y1. I don't know why I'm giving a math lesson. I don't even think it's it's even worth giving this. And this is just nothing but x2 minus x1. I mean, this is pretty common sense, right? But hey, I'm bored, so might as well do this. Okay, and what else do we know? Well, we also know this, right? We also know the length. We also know the length of this part, and that's nothing but b1 minus x1. So now, using the laws of similar triangles, knowing that knowing that tangent of using the tangent so basically the tangent, this is what we're going to use, the tangent of theta, let's just say this is theta, is equal to what? The opposite over the adjacent. And so we actually have two thetas here, where we have this theta for the big triangle and we have this theta for the small triangle. Now, the laws of similar triangles is that this theta is the same for this small triangle and the same for this big triangle. So what we're going to do is very simple. Whoa, what is this? All we're going to do is solve for y. So opposite, which is the question mark, we're looking at the on our left side of the equation. Let's first have the our small triangle. So question mark over adjacent, which is b1 minus x1, is equal to, let's put it in the bottom here, is equal to opposite of the big triangle, which is equal to y2 minus y1 over x2 minus x1. And then all we do is solve for y. I mean the question mark. And so that's what we're going to do here. Hope that made some sense. So let's program this in. It's really pretty simple. Let's go back to our platform class right over here. Okay, so for int I equals 0, I less than section dot pieces dot size, and if section dot pieces, I mean, sorry. Avoid null pointer exceptions. We're just going to set this to that, and then we're gonna plus equals 4, because remember we're presenting 4 points for one slope, so that's why we're incrementing by 4. So we're checking all the slopes in this piece, if there are any. That's why we check if it's null or not. Okay. So remember Remember that this is how we're storing the information. So what we're going to do is just very simple. We need to find out the y-val at the given x location. So that's very simple, right? We already solved for it, and that's exactly what we're going to do. We're just going to solve for the question mark. So slope j plus 3, and again just refer to this. This is 0, 1, 2, 3. Okay, so refer to that, minus slope j plus 1 divided by slope j plus 2 minus slope j multiplied by the actor dot location dot x, as we said, minus the slope minus x1, which is j. But we're not quite done yet. Why are we not quite done? Because we need to add slope j plus 1. Why are we adding y1? Well, let's check it out. We're adding y1 to the solution that we get because, remember, we're subtracting y2 minus y1, which gives us a length, and that basically ignores where we were at in the scene, which is at y1. So we lose that information, so we need to add that back in. So that's all we're going to do. Because look, just take a look at this. We're solving for this, right? This is what we solve for. This is y. This is the question mark. That's just nothing but a length, but we're trying to find this point. So we need to add this length with y1, which starts over here. So y1 plus this length gives us this y value of this point. That's all it is. That's why we need to add y1. Or you can, subtract. No, you can't subtract. No, never mind. Just add y1. Okay, and that's it. That is it. Now we have x1, y1, y1, which is equal to y2. Sorry, just y, and x2, just like hit platform apostrophe. Okay. And now, so now what we're going to do, now that we have the y-val, we're going to do something very similar to hit platform, but not quite. It's actually going to be a lot easier now that we have this. So we're actually not going to detect, we're not going to care about the direction up, right? Because if we are under a slope and we jump up, we wanna ignore the ceiling. So we're not gonna detect ceiling that is a slope, right? If you're under a slope and you jump up, you're just gonna pass through the slope. That's what we want. That's what I want. That's what I have in mind. So we're just gonna detect for the case in which the direction of the speed is going down, right? So that we have our code is a little bit shorter than hit platform for hit slope. Okay. So what we're going to do again, just like what we did before, we're going to check if within the x range, right? And that's what we did here. We first checked if we are within the x range, right over here. And as a matter of fact, what we're going to do is, well, let's not copy and paste, because I find that by copying and paste we get a lot of errors, and I don't think it's worth it. So actor.location.x has to be less than or equal to the slope j plus 2, which corresponds to x2, and actor.location.x has to be greater than or equal to slope j. Okay, this is the our initial x location prior to adding the dx. So now let's check. We're going to actually put the same thing that we did, or we're still inside after adding our after the change in x. So we're just going to copy and paste this right over here, and copy and paste that over here, and just add the dx. I hope this is making some sense. It's pretty simple and actually quite flawed, and I'll show you the flaw that we're going to have by doing this. Okay, so what we're going to do is we're going to traverse the slope if we are on it prior to this check. Alright, so if actor.location.onSlope actor, we're just going to offset our actor's y location with the y val, and of course our actor's y location represents the center of our actor. So what we want to do, but we want to actually offset it, but we actually detected the feet, which is actor.location.y minus half of the actor's height. So what we're going to do is add in that half. And then we're just going to return true because we did hit a slope. I mean, we were already on a slope, but we're still on a slope. Ugh, new line just for this. Well, just delete the check. Pretty sure you can understand what that means. Otherwise, else, if we're not on a slope, we're going to check if we hit the slope. So we're going to determine if we hit a slope. So we're going to switch. Well, yeah, let's switch anyways, just in case we want to add ceiling detection for slopes. The feet of the actor greater than or equal to the y val. And so this is the initial position of the feet of our actor, and the final position of the feet of our actor passes that. So again, this is what we're doing. Is it in here? Nope. Is it in here? Yep. So initial position of the feet of our actor, and if the final position goes below this y val that we computed, then we hit a slope. And this equal sign is crucial. This equal sign is crucial, so don't forget them. Now again, at this point, the dy is negative because the direction is down. The dy that gets passed in, at least. Okay. Now, if this is true, what we're going to do is actor. Well, we're going to do the same thing right here. And then we're just going to set the actor dot on slope, sorry, location dot on slope equal to true, and just return true. Truein. And of course, we're just going to break here. Case is direction up. We're not going to do that for now. And it's very easy, just copy and paste, but we don't want ceiling detection for hit slope. I mean, that's just me. We can always add it by copying and pasting this, but not now. And if we didn't hit a slope, we're just going to set actor.onSlope equals false and return false. All right. Now, there's actually a big flaw in this, and I'll show you what I mean. Now, let's actually use this. Let's go back to our location, and this is going to get a little tricky, and it took me a while to get this, but I'll try to explain as best as I can. What we're going to do in here, now remember that we have two things. We have platforms, horizontal platforms, and we have slopes. Both of them influence the y value of our actor. Only the y value, right? We don't care about the x value. Only the y value. Both of these methods can offset the actor's y value depending on whether they hit a platform or not, or hit a slope. Now later on we will do take care of the wall detection, which will only influence the x value of our actor. So this is where it gets tricky, and this is very important that we first detect if we hit a slope, right? And then we need this end over here. This is very important. We need to detect slope first, and I'll tell you why soon enough. But so let's actually test this out, see what we have. Right? So run history. Whoa. Okay. And we're getting a null pointer exception. Why? For section pieces. Ah, right. Again, to avoid null pointer exceptions, when we're setting the section, if no sections was set, return false. Okay. Now, if we okay, we can't move around because we still have that accelerometer on. So, and I lost my camera focus. Oh, I hate that. I hate that so much. Okay, let's just go to our HUD, and what we're going to do is just comment this out over here on update. Okay, and then run it again. So now let's take a look if our slope detection works. It works, right? So we're getting offset. So pretty cool. Now, this crucial thing over here. Let's go back to our location. I said it's very important to detect the slope first. Well, you can detect the platform first, but we're going to detect the slope first, and I'm going to explain why in just a second. So if we detect the slope first, and this returns true, this thing is going to get negated and this will return false. Now if false and whatever, the Java compiler will not even if this returns false collectively after negating it. So if we hit a platform, this will be false because of the apostrophe. If it is false, we're not even going to execute this line of code over here because the logical end needs for both to be true. And since this is false, there's no point in checking. So that's what the Java compiler does. So it's not even going to execute this line of code, and we're just going to move on to this here right away. Now, what if it's false? What if we did not hit a slope? This will return false, and then you negate it, this will return true. And so we're gonna move on over here and then check if we hit a platform. Now, if we don't hit a platform or we don't hit a slope, then we're not going to change. Then we're going to change our y based on the dy. Otherwise, we're going to set, right? And there's also another reason why we want to check for whether we hit slope first or not. Now let me show you what the problem that we have is right now. You're going to see that we're actually going to fall off our platform. Off our slope. Look, check this out. Oh no, we fell off. And I'm going to explain to you why that's happening. Because this is our implementation of slopes. So let me show you again. There's no problem going down the slope. But when going up the slope, you're going to see that we're going to fall off of this before we even get to this platform over here. So just move right. We're going to fall. Watch. We fell. And now I'm going to try my best to explain what's going on. And let's just create a new one. All right. So let's take a look at our bridge, right? This is the geometry of our bridge. We have this, this, that, that. So let's just redraw our bridge, just the outline. So this is our bridge. Ugh. Right? This is our bridge. The platform detections of our bridge, at least. So let's again do this with GIMP. So let's take a look at what's going to happen. Our cat falls down and he's on a platform. Now when he starts moving right, what's going to happen is the platform doesn't end until over here. And by this time, we've already passed the And by this time, we've already passed the we didn't detect a slope because, well, the y point over here is not anyways, this just doesn't detect the slope. We just keep moving to the right and we don't detect the slope, and we fall. So that's what's happening there. And on the case that we are going up, what's happening is that we go over here, and then at this point the slope ends. So we're no longer in a slope, and then we're going to start, but we're going to keep moving over here. But as you can see, our initial y value Y position of our feet is not above this platform over here. It's actually starting below, so we're not even going to detect this platform over here, and we're just going to fall. So that's what's going on. Now the solution that I came up with is a naive solution, but nonetheless works for the most part. So let's just erase this. So what I did was, instead of the slope starting at being connected, having the same y value initially as this platform over here, what I did is I'm saying that the slope starts at this height and ends, can't draw a line. Let's use a path. It ends over here. And let's just modify this a little bit. Okay. Now you must be looking at me like, whoa, what are you doing? This is stupid. This is retarded. Are you stupid? Yes, I am stupid. But hey, you know, whatever works. Whatever works, works. Like, you must be looking at me, well, that's not even connected. Are you retarded? I don't think I'm retarded, but whatever you say. So what we're going to do, so what I did was, and this is why we need to detect the slope first, because this is what's going to happen. If we start walking to the right, well, we're not going to detect the slope, and we're just going to fall down. So what I did is I have two different detections, two different y coordinate for detections for detecting the horizontal platform and detecting slopes. So for the horizontal platform, I'm checking for horizontal platforms using this y value over here, the feet. However, I'm going to detect the slopes platform using this y value over here. Okay? So now when we're moving, when the cat is moving, we're on a platform, and then we hit this platform, and then all of a sudden, oh hey, we're in a platform. Oh, we're in a slope. We had a slope because even though we're setting our speed equal to 0 whenever we're hitting a whenever we're on a platform, remember, when we're on a platform, we're on the state of falling. And when we're falling, we're accelerating downwards, meaning our dy is actually equal to decreased vertical speed. It's actually equal to negative vertexel, which is equal to -4. Right? So our dy all the time when we're on a platform is actually -4. So this allows us to say that, okay, initially, when we're checking for a slope, this is the slope checker right over here. This is the point for checking slopes, and this is going to be the point for checking platforms. Now, we're on a platform, but remember that we're checking for slopes first all the time. So even though we're on a platform and we hit here, and then since our dy is always -4, we're going to check, okay, initial y, final y, yes, we hit a slope. So what are we going to do when we hit a slope? We're just going to displace the location of our actor by the slope, and we're going to say that, okay, we hit a slope, so we're going to displace our location of our actor here, right at this point right here, and then we say that we're on slope, and then we're just going to traverse this slope over here until, now that's not actually the image. The image is this, right? Because this is the point in which we're checking for the slope. This is the point that we use to check for slope collision. So we're actually going to go up this slope, right? Like this. We're going to traverse the slope, and then at this point, And that's why it's a little bit above the platform, because look, right, we're going to be finished traversing the slope, and at this point, if we move a little bit further to the right, we're no longer in a slope, and then we're going to need to detect if we are on a platform. And then so we're going to fall down, and yes, we are on a platform, and then we're just going to continue. And the same thing applies if we're moving to the left. Or we're on a platform, and then we're no longer on a platform, we start to fall, and then we detect the slope using this point over here. And then we're going to traverse downwards, traverse the slope, until we're no longer in a slope, and then we fall down, and then we hit this horizontal platform, and then we're on a platform. Right? So yeah, it works. Okay, and let me show you the reason for this thing over here. If we say that this ends here, what is going to happen? If this ends here and we traverse the slope, we're on a slope and we're traversing the slope, we're going to go here, and at this point in time, we move a little bit further to the right and we're no longer in a slope, and we're going to start going down. Now the problem is we're using this y value over here, the feet, to detect the platform, not this. So initially we're already below the platform, so we're not even going to detect that we hit the platform. So we're just going to fall down. Right? Does that make sense? I hope you guys are following this. So that's why we need that that extra boost up there. Now you might be thinking that, well, this is not going to look right. But remember, we're not going to be, this line over here is going to be invisible. When we were, if we open up our bridge, when I was plotting in the points for the slope for the bridge, the points that I saved were not these points over here. It wasn't this. No, it wasn't this point, and it wasn't this point. What I did was very simple. Whoop. What I did was actually over here. I just displaced that over here, so that you might be thinking that, oh well, it's not going to look right, but trust me, it's going to look right. So this is an invisible line for slope detection. Now let me show you why this is a little bit above the slope and it's not connected. What if this goes all the way down? What's going to happen? Geez, my voice is cracking. What's going to happen? So let's take, let's say we're going down the slope, right? Again, we're detecting, we're using this y value or some y value above. And we're going down the slope. Remember that we're always checking for the slope first. So what's going to happen is we're going to go all the way down here. And at this point, we move a little bit to the right. We're no longer traversing the slope and we're no longer in a slope. Now, can you see the problem? The problem is that the point, the feet, is already below the horizontal platform, and what's going to happen is we're just going to fall. So that's why we need it to be a little bit above that. So so that once we are going down, we're no longer on a slope, and then say, hey, our y value. As a matter of fact, this is not even correct. It's just a little bit more. Going down, then we're no longer in a slope, and then we're still falling, but we detect that we hit a platform, so we're in a platform. It works. Right? It is going to be a little bit, you're going to see a little bit of a flaw when you're playing the game, but that's just a little bit. You're going to be seeing like a little bit that our actors are going to be a little bit displaced at this junction over here. because yeah, it's going to be a little bit displaced, maybe 2 pixels displaced, but other than that, that's really all the drawback is with this implementation. And I guess I missed something. We actually need this to be like this, to be forking, to be crossing each other. And I'm not going to explain why, you guys can figure it out. So for this platform, it's going to be crossing each other. So you can see this, it's crossing each other. And just trust me on this one, I don't want to have to explain it, take another 15 minutes to explain why it needs to be crossed. I don't think it needs to be crossed, but just do it anyways. Alright, so that's it. That's our slope detection. So in order to fix our current problem, the simple solution is going to be, so we still have that problem, right? We're still falling. Right, because we're using, if we go to our platform, we're still using the same Y location to check for slope detection as we are using for the platform horizontal detection. So the simple solution is just declare this constant. We're going to call it private static final slope detection offset. We're going to set it to 50.0f. Now it doesn't need to be 50, it could be 20, it could be 30, it could be 40, it could be 50. But I just find that 50 works best. It's a float. So we're going to find this is on our hit slope, direction down, instead of our initial, this is our initial y value that we're checking for. We're just going to add it in here. Other than that, that's the only thing we changed. And with that move, we have solved the problem. But we still have another problem. You saw that, right? We still fell when we were at above. And I don't want to have to explain this. So let me just tell you the solution for that. The solution for that is that whenever we're on a slope, we need to slow down whenever we're on a slope. So in here, before we even offset our x, right after we calculate our dx, if we're on slope, we're gonna multiply our dx by 0.4. So meaning we're gonna decrease our dx by 60%. Our speed, our velocity in the x direction by 60% if we're on a slope. Should I explain this or not? I already threw away the picture. Well, let me just try to explain this in words. Why we're doing this is because so decrease dx while on slope to patch up our flaw slope detection algorithm. So this is just a patch, nothing but a patch to because our slope detection algorithm is flawed. It's stupid, but it works if we just do this. And this is not magic, and I don't even know if I should explain this to you. I think I've already spent enough time explaining what the hell is going on. But let me just try and explain to you what's going on. Because if we don't do this, say our dx is large, And I guess I really can't explain this without having to draw it. Say we have a slope over here. And then we have a platform right over here. Let's take our cat. And we're, again, because of that offset, we're going to detect our detection for slopes is somewhere over here, plus 50. Okay, so what's going to happen is, if we're going here and our dx is fast, now at this point, and remember that we're detecting platforms using that point y value. So if we are moving too fast, what's going to happen is, initially, are we still on a platform? Yes, we are. But then if we suddenly move so fast that our dx, when we add our dx, well, are we still on a platform? No, we're no longer on a platform. And as you can see, since we're no longer, are we still on a slope? Yes, we're still on a slope, but after a large amount of dx, we're going to find that we're going to go here, and then all of a sudden, are we still on a slope? No, we're no longer on a slope. And so we're going to fall because look. Sorry, let me just extend this a little bit. So are we still on a slope? Yes, we're still on a slope. But if our dx is so large, large enough, at this point, the next time we check if we're on a slope, then we add in our dx, we go over here. Are we still on a slope? Sorry. And then once we add our dx, and remember we're still here, and then we add our dx, then at this point we're going to check, are we still on a slope? No, we're no longer in a slope. But are we on a platform? No, we're not on a platform, so we're going to fall down. That's why we need to limit our dx. So if we just go at this smoothly, and I'm not sure if my explanation is making any sense. Probably not. So okay, let's say this is our initial x position, and then on the next one, once we add in our x, we check. So for a big dx, we check, and then we end up over here. Are we still on a slope? No, we're no longer in a slope. So we're not even going to offset our character over here where it needs to be. It's going to be over here, in which case it's going to fail to detect the horizontal platform, and it's going to fall. So that's why we don't want a large dx. We don't just want to go from here and then suddenly go the way over here, and then we're no longer in a slope. We want a certain maximum x value such that, okay, we're slowly going up. We're still on a slope. 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 And at this point, we're no longer in a slope. But as you can see, we're going to successfully detect platform detection. So I hope that kind of made sense. If not, I'm sorry. That's the best explanation I can give you. And with this, we now have a working platform detection. Platform and slope detection. Right? Whee! Hadouken! Hadouken! And then next time we're going to add in visual effects, and we're going to add in extra effects for these special moves. So look forward to that. And I do see something else though. If we take a look, see our animation delay is, and see, here's the flaw that I'm talking about here. You see right there, our feet is a little bit above the ground at this point. But that, that's a small price to pay for making this work. As you can see, it abruptly, but it's a small price to pay. This is going to be an action game, and they're probably not even going to notice it most of the time. So, and it's not game breaking, isn't it? Is it? It's not game breaking, so it's not too bad. And I guess this is the price you pay for not using tiled. For there's got to be a better way of doing this. I mean, the way I did it is the naive way of doing it, but hey, it works. And you know what? There's one more thing that I want to do before ending this video. Is you see the steps when we're going up the slope? It's the steps, the amount of change in the frame, the animation delay is a little too small where we're on a slope. So we want to slow down our animation whenever we're on a slope. So the way we're going to do that is simple. We're just going to go back to our Nekko sprite right over here. And we're going to go back down to switch horizontal motion state. Now, if we are moving, what we're going to do is we're not just going to set the animation delay to 2.0. We're going to slow it down if we're on a slope. So if actor dot on slope, we're going to set our animation delay. We're going to slow it down a little bit, equal to twice this. Should be 4. Else we're not on a slope, so just that. So now if we run this, the animation should be a little bit slower for the walking animation loop whenever we're on a slope. Right there. So again, we're going to work on the combat moves on the next video, and we're going to add in effects as well as game logic for all of the combat moves. So for this one, Shoryuken, sorry, right? We're going to do something like, sorry, something like that, right? And then add in like after images. Well, we're going to do that next video, so look forward to it. Until next time, I guess I'm going to go to sleep. I'm going to go to bed, go to sleep, and then wake up again tomorrow and start coding right away, because our deadline is Monday at midnight. So I hope you guys learned something, learned a little bit of math. If not, then you should have just skipped those parts. And really, we didn't do much. All we did was make this one method, and the entire video was basically me trying to explain, trying to be a math teacher, even though I don't have the right to, the credentials to teach anyone. Again, these are not tutorials, especially not math tutorials. But hey, I did what I had to do. So let's just close this for now. So we're done for our platform detection for now. And then, we can always add in the wall detection later. the vertical platforms. I mean vertical, yeah, vertical platforms, the walls. We're gonna add that in later. For now, we don't need it yet. The location, this should be it for our location, you know. And then next time we're gonna work on our Nekko and Nekko sprite. So look forward to that. Until next time, I'll see you guys. Peace out and have a good night and sweet dreams.